The concept of submarines dates back to the 17th century, with the first documented submarine being designed by Dutch inventor Cornelius Drebbel in 1620. However, it wasn't until the 20th century, particularly during World War I and World War II, that submarines became essential in naval warfare, evolving into sophisticated vessels capable of extended underwater operations. The mystique of submarines. Submarines are some of the most intriguing and mysterious vessels in the world's naval fleet. These underwater ships can operate undetected beneath the ocean's surface, conducting a variety of missions, from military operations to scientific research. But how exactly do submarines navigate and operate underwater where traditional means of navigation, like GPS, don't work, and where the environment is completely different from the surface? The basics of a submarine at its core: a submarine is designed to function both on the surface and underwater. The hull of the submarine is typically made from high-strength steel or titanium to withstand the enormous pressures found in deep waters. A submarine has two main hulls: an inner hull, which is the crew's living and operational space, and an outer hull, which provides hydrodynamic shape and protection. Submarines are powered by nuclear reactors or diesel-electric engines. Nuclear-powered submarines can operate for months without surfacing, as they generate their power from nuclear fission, which provides a continuous supply of energy. Diesel-electric submarines, on the other hand, need to surface more frequently to recharge their batteries, but they are quieter and more difficult to detect. The science of submersion, ballast and buoyancy. The ability of a submarine to dive and surface is governed by the principles of buoyancy, which is managed through the use of ballast tanks. These tanks can be filled with either water or air. When the tanks are filled with water, the submarine becomes heavier and sinks. Conversely, when the tanks are filled with air, the submarine becomes lighter and rises to the surface. The process begins when the submarine needs to dive. The crew opens valves at the top of the ballast tanks, allowing water to flood in while air is expelled. This increases the submarine's overall density, making it sink. To surface, compressed air is blown into the ballast tanks, forcing the water out and reducing the submarine's density, causing it to rise. The submarine also maintains its depth through fine adjustments using smaller trim tanks and the plane's horizontal rudders. The crew can manipulate the angle of the submarine to move it up or down in the water, a process known as trimming the submarine. Unlike surface vessels, submarines cannot rely on visual landmarks, and traditional GPS systems don't work underwater because satellite signals cannot penetrate deep water. Inertial navigation system, INS. Submarines primarily use an inertial navigation system, INS, to navigate underwater. The INS is a highly sophisticated system that uses gyroscopes and accelerometers to track the submarine's movements relative to a known starting point. By constantly updating the submarine's position, the INS allows the crew to know where they are at all times, even when they are deep underwater and far from any land-based references. However, because the INS is based on dead reckoning, it can accumulate errors over time. To correct these errors, submarines periodically surface to get a GPS fix or use other methods like underwater navigation aids. Sonar, the submarine's eyes and ears. Sonar, sound navigation and ranging, is another critical tool for submarines. Sonar systems work by emitting sound pulses and then listening for their echoes. By measuring the time it takes for the echo to return, the sonar system can determine the distance to an object, such as the seafloor or another vessel. There are two main types of sonar: active and passive. Active sonar emits a sound pulse and listens for the echo, which can reveal the location of objects or other vessels. However, using active sonar can also give away the submarine's position, as the sound pulse can be detected by others. Passive sonar, on the other hand, involves listening to sounds in the environment, such as the noise made by ships or marine life. Passive sonar allows the submarine to detect other vessels without revealing its own location, making it an essential tool for stealth operations. Staying connected while underwater communicating while submerged is another challenge for submarines. Radio waves, commonly used for communication, do not travel well through water, especially at greater depths. Submarines typically communicate using very low frequency, VLF, or extremely low frequency, ELF, radio waves, which can penetrate water to some extent. However, these frequencies have limitations, including low data transfer rates, so communication is often limited to short, encoded messages. For more detailed communication, submarines need to surface and extend a communication mast above water.